So blockchain does not make you decentralized. It doesn't give you any freedom at all, actually. It enslaves you. And it's crazy to me how we have all these software nerds and all these tech guys that are so, oh, blockchain, we're going to be free. We're going to be on Web3. No, you actually just signed away your death sentence and you gave them full control over your entire body. Now I'm going to try to explain to you how blockchain is connected to all of this tech. We're going to read Blockchain Explained in under 100 words. I recently attended an industry seminar where the concept of blockchain was explained. At the end of the session, walking out of the lecture room, I heard one of the attendees say to a colleague, "I'm still not sure what exactly blockchain is." Many of us know that blockchain is a topic that is hot at the moment. It's a topic that is disruptive. It's a topic that is accelerating. And that may be our elevator pitch. Here's our attempt to explain the original intent of the blockchain in fewer than 100 words. You, a node, have a file of transactions on your computer, a ledger. Two government accountants, let's call them miners, have the same file on theirs, so it's distributed. As you make a transaction, your computer sends an email to each accountant to inform them. Each accountant rushes to be the first to check whether you can afford it and be paid their salary, Bitcoins. The first to check and validate hits reply all, attaching their logic for verifying the transaction. If the other accountant agrees, everyone updates their file. This concept is enabled by blockchain technology. So, let's start with the first paragraph. Where in this paragraph are you decentralized? You're not. You've got two accountants that are receiving your ledger. And right away, it says you are a node. The very first thing, it says you're a node, so you're not decentralized. Let's go to Wikipedia and read their explanation of blockchain. A blockchain is a distributed ledger with growing lists of records, blocks that are securely linked together via cryptographic hashes. Each block contains a cryptographic hash from the previous block, a timestamp, and transaction data. Since each block contains information about the previous block, they effectively form a chain, with each additional block linking to the ones before it. Consequently, blockchain transactions are irreversible in that, once they are recorded, the data in any given block cannot be altered retroactively without altering all subsequent blocks. Blockchains are typically managed by a peer-to-peer, P2P computer network for use as public distributed ledger.
So, why didn't they tell you that you are attached to the cloud since 1995? Why didn't they tell you that you are a node on the network? Why didn't they tell you that you are creating Bitcoin from your own red blood cells using something called molecular communications routing?
We're going to Google molecular communication and click on the Wikipedia link. Molecular communication systems use the presence or absence of a selected type of molecule to digitally encode messages. Digitally encode. It's a digital signal encoding your body from the inside out. Now let's go over here and read. This is from the IEEE, Transactions on Biomedical Engineering, and this was released on December 6, 2013. So 11 years ago, a molecular communication system model for particulate drug delivery systems. And once again, this is from Professor Achilles. The goal of a drug delivery system is to convey a drug where the medication is needed, while at the same time preventing the drug from affecting other healthy parts of the body. Drugs composed of micro or nano-sized particles that are able to cross barriers, which prevent large particles from escaping the bloodstream, are used in the most advanced solutions. Molecular communication is used as an abstraction of the propagation of drug particles in the body. Molecular communication is a new paradigm in communication research, where the exchange of information is achieved through the propagation of molecules. Here, the transmitter is the drug injection, the receiver is the drug delivery, and the channel is realized by the transport of drug particles, thus enabling the analysis and design of a particulate drug delivery system using communication tools. This is achieved by modeling the molecular communication channel as two separate contributions, namely the cardiovascular network model and the drug propagation network. The cardiovascular network model allows to analytically compute the blood velocity profile in every location of the cardiovascular system, given the flow input by the heart. The drug propagation network model allows the analytical expression of the drug delivery rate at the targeted site, given the drug injection rate. Numerical results are also presented to assess the flexibility and accuracy of the developed model. The study of novel optimization techniques for a more effective and less invasive drug delivery will be aided by this model, while paving the way for novel communication techniques for intra-body communication networks. Again, for intra-body communication networks.
Yeah, so all these nerds and all these cyberpunks who think that they're so cool and so smart because, they pretend that they're smarter than everybody else, they literally fail to mention to everyone that you are a node on a network. So you're so smart, but you don't know you're a node on a network.